You think you know how pirates quench their thirst? Rum? Rainwater? Those are myths that would have killed you in the first 3 days. The truth lies in a simple device an old bosun would build from scraps. Today, I'll show you a forgotten technology that turns salty poison into a source of life. And by the end, you'll understand why it's still used in space. A person can survive 3 weeks without food, but only 3 days without water. On the 3rd day in the tropics, organ failure becomes irreversible. A direct descendant of this technology, known as the water recovery system, now provides water for astronauts on the ISS. The question isn't what they drank when the water ran out. The question is how they created fresh water from literally nothing, hundreds of miles from land. It wasn't rum or a chance downpour that saved them from an agonizing death. They were saved by an ingenious method. It's the sailor's greatest paradox, to die of thirst while surrounded by millions of tons of water. It's like being locked in a grocery store where none of the cans have an opener. Salvation is near, yet unattainable. In the next few minutes, we won't just reveal this secret, we'll understand why salt water is the perfect killer. It contains 35 grams of salt per liter, while our kidneys can process no more than 9. We will break down the construction of their life-saving device step by step. And you'll be shocked to learn how this pirate life hack formed the basis for modern survival technologies. Now, stop for a moment. Picture yourself on that deck. The water is gone. Your only supply is the endless salty ocean. Your first move will determine everything. And most people make the same fatal mistake. Driven by desperation, they take a sip of seawater. It's instinct, but it's like taking off your clothes when you're freezing. A dehydrated brain gives the worst commands, and that sip is the first step into hell. But there's another instinct, to drink what's on board, rum. This is the second trap. Alcohol is a diuretic. It forces your kidneys to expel more fluid than you take in. Every gulp of rum didn't save them. It accelerated dehydration. Studies show that for every gram of ethanol consumed, the body expels an additional 10 milliliters of water. A single 50-gram shot of rum means losing half a liter of precious fluid. You're not extinguishing a fire with gasoline. You're paying for that gasoline with your own blood. The second option is to hope for rain. But the dead calm is called dead for a reason. The weather might not change for weeks. Relying on chance in the ocean isn't a survival strategy, it's a form of suicide. This is especially true in the horse latitudes, the zones between 30 and 35 degrees where the trade winds die down. Spanish galleons would get stuck here for weeks. Legend has it, they threw horses overboard to conserve water, hence the name. They needed a method that would always work, as long as the sun was shining. So rum kills. There's no rain, and all around are trillions of liters of water, every sip of which brings death closer. To understand the brilliance of their solution, we must face the real enemy, and it's not thirst, it's ordinary salt. As the poet Samuel Coleridge wrote in The Rime of the Ancient Mariner, "Water, water, everywhere, nor any drop to drink." That line is an epitaph for thousands of sailors. Salt does its work at the cellular level. Every cell in your body is a tiny pouch of fresh water. When you drink seawater, the salt outside creates such an aggressive environment that water is literally sucked out of your cells to dilute it. This is called reverse hydration. To understand the process, imagine what happens to a slug when you sprinkle salt on it. It shrivels and dies because the salt draws all the water out of it. Seawater does the same thing to every cell in your body. You dry out from the inside. This is not a quick death. First, the kidneys shut down, overwhelmed by salt. Then, delirium sets in. Sailors would see ghosts or land where there was none, and often throw themselves overboard in a final fit of madness. The ocean didn't just kill, it drove them insane. This isn't a theory. After the sinking of the USS Indianapolis in 1945, hundreds of survivors were left in the ocean. Unable to bear the thirst, many began drinking seawater. According to eyewitnesses, they quickly became delusional, shouting about fresh water on the horizon, and then died in convulsions. Now, put yourself in the bosun's shoes. You see young sailors secretly starting to drink salt water. You know that in 12 hours, they will become uncontrollable, and in a day, they will die in agony. Your job isn't just to find water. It's to save the crew from itself, using only what's lying around on deck. Old sailors called it salt madness. A person ceased to be himself, and your task as a leader was to conquer not only thirst, but also this insanity. The problem seems unsolvable. How do you separate water from what's dissolved in it? It's like trying to get sugar out of already stirred tea. It seems impossible. But the solution was brilliant in its simplicity. It didn't fight the ocean. It copied the most fundamental process on planet Earth. The genius of the pirate method was that they didn't try to pull the salt out. They figured out how to make the water itself escape from the salt. Behold, the sea alembic, or solar still. No complex mechanisms, no magic, just 4 items found on any ship: an old kettle, a piece of dark canvas, a small stone, and a mug. The genius of this method lies in its ultimate simplicity. In its various forms, this method is still described in the world's foremost survival guide, the SAS Survival Handbook by John Lofty Wiseman. It's a technology proven over centuries. Assembly took 2 minutes. They poured salt water into the kettle. In the center, they placed an empty mug to collect the fresh water, its rim higher than the water level. The kettle was then tightly covered with a piece of dark fabric. It had to be dark. That was the key. Why dark? Because black absorbs up to 98% of sunlight, converting it into heat. A light-colored fabric would have reflected the light, and the process would have taken much longer or not started at all. This was a crucial element, not a coincidence. The final touch was placing a small weight, a stone or a cannonball, in the center of the fabric to create a slope. Now, all they had to do was wait. The sun did all the work. The stone acted as a director. Without it, condensed droplets would have fallen randomly across the entire surface, some back into the salt water. The stone, however, created a single low point, commanding all the droplets to gather there and fall precisely on target. The dark fabric absorbed sunlight, heating the water in the kettle. The water began to evaporate, but the salt, being heavy, remained at the bottom. Pure water vapor rose, touched the fabric, condensed, and dripped directly into the mug. Drop by drop. The purest, fresh water. On a sunny day, such a simple setup could produce half a liter to a liter of pure water. Not much? When it's a matter of life and death, every sip is another day. A crew of 20 with several of these devices could hold on. Let's evaluate the technology. Efficiency, 10 out of 10. Resource availability, 10 out of 10. Assembly difficulty, 1 out of 10. This is possibly the most effective and low-tech survival device ever invented by man. If this device were a weapon, it would be the AK-47, utterly simple, reliable, built from available materials, and functional in any conditions. It is technological perfection in its simplicity. It looks like a miracle, but behind it is a fundamental law of physics that governs the weather on our entire planet. In essence, they didn't invent anything new. They cracked the weather's code. They took a global process and made it work in one small pot. The secret is in the weight. A water molecule is light. When heated, it easily turns into vapor and rises. A salt molecule, however, is a heavy brute. It needs much more energy to lift off the surface. The sun provides just enough heat for only the water to take flight. Imagine a playground. The water molecules are light, active children. As soon as the sun warms up, they scatter with shouts. That's the vapor. The salt molecules are their heavy parents, who remain sitting on the bench. The sun simply doesn't have enough strength to lift them into the air. But vapor isn't water yet. To catch it, you need a trap. The fabric served as that trap. Its inner surface was slightly cooler than the vapor. Upon contact, the vapor molecules lost energy, slowed down, and clumped back together into liquid droplets. Think of a bathroom mirror after a hot shower. Hot steam touches the cool glass and becomes water again. The pirates simply made this fogged mirror effect work for them. Essentially, they created a miniature version of Earth's weather system. The kettle was the ocean, the sun heated it, the fabric was the atmosphere where the vapor cooled, and the drops in the mug were their own personal, controlled rainfall. The irony is that the water obtained this way was purer than any spring water, Distillation is a process that removes not only salt but also 99.9% of all bacteria, viruses, and heavy metals. They were getting not just drinkable water, but medically sterile water. The most interesting part is that you can replicate this experiment right now. Take a bowl, pour in some salt water, and place an empty glass in the center. Cover it all with plastic wrap and put a small stone on top. Place it in the sun. You will see with your own eyes the physics that saved lives. Don't be surprised if the resulting water tastes flat or bland. That's because it lacks the minerals we're used to. This is the taste of pure H2O, the very taste that saved lives. But pirates weren't the first. As far back as the 4th century BC, Aristotle observed that when seawater evaporates, the salt does not rise with the vapor. In his work Meteorology, he wrote, "Salt water when it turns into vapor becomes sweet, and the vapor does not form salt water when it condenses again." This knowledge was lost and rediscovered many times. Arab alchemists perfected the method, creating alembics for distillation. Pirates merely adapted ancient knowledge for extreme conditions. But the story doesn't end there. This same principle, distillation, is the basis of modern maritime survival systems. Huge desalination plants operate in the same way, just on an industrial scale. And yes, the life support system on the ISS uses an advanced distillation method to purify and reuse every drop of water. It recycles about 93% of all water on board, including sweat, moisture from breath, and even astronauts' urine. As they say at NASA, today's coffee is tomorrow's coffee. And at the heart of it all is the same pirate principle. From a pirate's kettle to a space station, it's the same idea. It's a single golden thread of brilliant thought stretching across millennia. From an ancient Greek philosopher, through a pirate ship, to an orbital station. And this simple yet timeless principle teaches one main lesson. And this lesson can be boiled down to a 3-rule survival protocol. First, doubt the obvious. Instinct screams, drink what's available, but rum is a trap. Seawater is a death sentence. The most accessible resource is not always the safest. Second, copy the genius. Nature is the best engineer. It solves the problem of desalination every day on a planetary scale and has for billions of years. You don't need to invent, you just need to observe and copy its laws on the scale of your kettle. Third, find treasure in trash. In the most desperate situations, the solution is often shockingly simple and already at your fingertips. An old piece of cloth, a stone, a rusty kettle. This isn't junk. These are the parts of a life-saving device. The story of the Solar Still is not just a tale about pirates. It's a hymn to human ingenuity, born on the edge of life and death. It's the ability to see not a problem, but a physical process that can be understood, hacked, and turned to your advantage. It is a monument, carved not from stone, but from the very idea of survival. The idea that understanding the laws of the world is always more powerful than the brute force of circumstance. And now, the main question for you. What in this story amazed you more? The brilliant simplicity of this method, or its enduring legacy that has reached our time and is used in space? Write just one word in the comments, simplicity or legacy. Let's see which one gets more votes. Simplicity, the fact that it can be assembled from junk in 5 minutes. Legacy, the fact that the very same idea supplies people with water in orbit today. Which of these blows your mind more?